Good day. So in this question, we're going to talk about convergence as well as divergence. Right? What does it mean to converge, and what does it mean to diverge? Right? So basically, to converge is to approach a certain value. If I'm gonna simplify it like that, so you approach a certain value, but you may not necessarily reach that value. When we diverge, so for example, arithmetic sequences, they diverge because you're starting off with a certain value. Let's say you start with the 2, and then you add a common difference, and then you add a common difference. So this becomes bigger and bigger. So if you started off here, it becomes bigger and bigger. Right? That is divergence. But with the convergence, you find that you start off with this value, but then you approach this specific value. You approach this specific value as you'd go with the sequence. You go with the sequence. You approach a specific value. So there's certain criteria that must be satisfied for a sequence to be convergent. Right? If a sequence is a geometric sequence, it can converge. It converges when the value of r, which is the common ratio. Remember, r is equals to tn plus 1 divided by tn. Right? If this value falls between here in this inequality, it's less than -1, as greater than -1 but less than 1. Therefore, if r is this, falls within this range, then that series will converge. Right? So here they are saying the following sequence forms a convergent geometric sequence. So they are telling you that it converges. And then they say determine the possible values of x. Write all the possible values of x that would make this series to converge. Because already they are telling you that it is convergent geometric sequence. So the first thing that you're going to do, you're going to calculate the value of r. R, I said, is tn plus 1 divided by tn. But in this case, you can use t2 over t1. Right? Then this is going to be equals to x squared divided by 5x, which is the same as x over 5. So that is the value of r. Right? And then now we're going to use that inequality because this is a convergent quadratic geometric sequence. So if -1 less than x over 5 less than 1, then now you're gonna solve this inequality for x. So now you have -5 less than x less than 1. So this, it covers all the values of less than 5, sorry. So it's less than 5. Less than 5. So this, it means that all the values of x that falls within this range, so x is elements of -5 to 5, but you don't include the 5s because this is exclusive, that sign, that inequality sign. So this is how you will solve a question like this. It's almost gonna be solved this way. And here they are saying if x is equals to 2, which is still within this series, meaning that when x was to 2, this series will still converge, right? So you know that sum to infinity, you're gonna use this formula of a 1 minus r, whereby r cannot be equals to 1. Because you don't want r to be equals to 1 because it's going to be undefined, this whole expression. Alright, so sum to infinity, it now becomes, the first term will just be 5 times, so it's going to be 5x, so it's going to be 10, because it's a 5x So you'll have 5 times 2, so this becomes 10. That is your A, or your first term, right? And then you're going to substitute it here. So you have 10, 1 minus R. R is what? R is X over 5. So you're going to put X where there is, you're going to put 2 where there is X. So it means it becomes 2 over 5. Then this becomes 10. So that's 5 over 5 minus 2 over 5. That is 3. Yeah, that will be 3 over 5. So we have 3 over 5. Then this becomes 10 times 5 divided by 3. Right? And then yeah, you just put this into your calculator. That's 5. Should be around, I think, 15, if I'm not mistaken. No, I think it's just say 50 divided by 3. I think we can simplify it. So 50 divided by 3. So that becomes the answer, sum of infinity. So sum of infinity, 50 divided by 3. Yeah, but you can just use a calculator as well. So yeah, this conclude this portion of this session. So now we understand convergence, right? So as long as this is satisfied, then the series or geometric series will converge. Thank you.